How do geologists use angles to understand rock layers?
Mathematics, especially geometry, is instrumental in understanding rock layers. In a branch of geology called stratigraphy, scientists measure angles and planes in rock in order to know the location of certain rock layers and the possible geologic events that affected the layers over time. In particular, geologists measure strike and dip. Strike is the angle between true north and a horizontal line contained in any planar feature, such as a fault, usually caused by an earthquake, or inclined bed, often caused by the uplift of hot molten rock around a volcano. Dip is the angle at which a bed or rock vein is inclined to the horizontal. It is measured perpendicular to the strike and in the vertical plane, as opposed to the strike's horizontal line.
What is operations research?
Operations research, more commonly called optimization theory, is a form of applied mathematics designed to determine the most efficient way of doing something by using mathematical models, statistics, and algorithms in the decision-making process. It is a branch of mathematics that entails the many diverse areas of optimization and minimization, including the calculus of variations, control theory, decision theory, game theory, linear programming, and many others. Operations research is most often used to analyze complex, real-world systems, stressing the improvement in or optimization of performance.
Why did the Egyptians choose the pyramid form?
Historians know that the Egyptian sun god, with its rays reaching for the sun, was represented by pyramid-shaped stones, or benbens. And because the Egyptians worshipped the sun as their chief god, the pyramids are thought to be huge renditions of the benbens. After a pharaoh died, the pyramids would be symbolic of the pharaoh ascending the sun's rays to join his sun god. Some historians also believe that the pyramids may have had some, still hidden, numerical significance. In particular, some believe the ratio of the pyramid's perimeter to its height times 2, or p/2xh, gives a close approximation to the value of pi. Another claim is that the slopes of the pyramid sides were also expressions of pi.
How are vectors added?
One way to combine vectors is through addition, or composition. This can be done algebraically or graphically. For example, to add the two vectors u-3, 1, and v5, 2. One can add their corresponding components to find the resultant vector r2, 3. One also can graph u and v on a set of coordinate axes, completing the parallelogram formed with u and v as adjacent sides. Obtaining r as the diagonal from the common vertex of u and v.
What were some of the first motor-driven calculating devices?
Many historians believe that the first motor-driven calculating machine was the Intrebari, a device designed by Czechoslovakian inventor Alexander Rechnitzer in 1902. The next step occurred in 1907, when Samuel Jacob Hirsch Stark (1867–1937) produced a motor-driven version of his Thomas-based calculators in Vienna. In 1920, a prolific Spanish inventor named Leonardo Torres Quevedo (1852–1936) presented an electromechanical machine wired to a typewriter at the Paris Calculating Machine Exhibition. His invention performed addition, subtraction, multiplication, and division, and then used typewriters as input/output devices. Interestingly enough, even though the machine made a hit at the exhibition, it was never produced commercially. More and more such calculating devices with electric motors were invented. By the 1940s, the electric motor-driven mechanical calculator had become a common desktop tool in business, science, and engineering.
What was Pythagoras' importance to mathematics?
Although the Chinese and Mesopotamians had discovered it 1,000 years before, most people credit Greek mathematician and philosopher Pythagoras of Samos, c. 582 c. 507 BCE, with being the first to prove the Pythagorean theorem. This is a famous geometry theorem relating the length of a right-angled triangle's hypotenuse h to the lengths of the other two sides, a and b. In other words, for any right triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the other two sides.
What are betting odds and how are they determined?
Betting odds are usually written in the form Rs, in which R is the chances for and S is the chances against. This can be stated as R to S or chances for to chances against, or S to R or chances against to chances for. But note that odds of 1:1 are said as 1 to 1, not 1 out of 1. Odds are usually calculated as follows: total chances equals chances for plus chances against, or chances against equals total chances for.
What are the foundations of mathematics?
The foundations of mathematics include how to formulate and analyze the language. You have to speak the right mathematical language to make meaningful mathematical statements, axioms. A statement accepted as true without proof, and developing logical methods in all mathematical studies. The most basic mathematical concepts in the foundations include numbers, shapes, sets, functions, algorithms, axioms, definitions, and proofs.
What is a microprocessor?
A microprocessor is a silicon chip that contains a CPU, or central processing unit, which is normally located on the main circuit board in a computer. In the world of personal computers, the terms microprocessor and CPU are often used interchangeably. These chips, or integrated circuits, are small, thin pieces of silicon onto which the transistors making up the microprocessor have been etched. The microprocessor is the heart of any normal computer, from desktops and laptop machines to a larger server. They have many uses. For example, they control the logic of almost all familiar digital devices, from microwaves and clock radios to fuel injection systems for automobiles.
What is an exponent in terms of algebra?
An exponent is actually raising a number to a certain power. This is written as a superscript to the right of a real number, such as 34, expressed as 3 raised to the 4th power, or 3 with an exponent of 4. For more information on exponents, see Math Basics. The exponent represents the number of times a number is being multiplied. The above example, for instance, actually means 3x3x3x3, which is equal to 81. The power can be an integer, negative or positive numbers, real number, or even a complex number. This can also be thought of as taking the quantity b, the base number, to the power of another quantity often called e, the exponent. In many computer-oriented texts, this is written as b(e). Exponents are important to algebra as they are often included in algebraic equations. The process of performing the operation of raising to a power is known as exponentiation. Exponents are also often associated with functions. For example, in the function f, x equals x2, the 2 is the exponent.
What is a set?
Simply put, a set is a collection of objects or entities. These are called the elements of the set. The number of elements in a set can be large, small, finite, or infinite. The informal notation used for sets is sometimes seen as x equals y, z, with brackets used to contain the elements within the set. It is stated as, X is a set consisting of the elements y, z, and so on. But more commonly sets are seen as capital letters and elements as lowercase letters. Such as A is an element of set A.
Are random numbers generated by a computer truly random?
For most general purposes, random numbers generated by a computer can be considered random. But in reality, because a computer follows a set of rules in any program, the numbers generated are not truly random. In order for a sequence or specific numbers to be truly random, they must not follow any sort of rules. That's something to think about the next time you purchase a computer-generated random numbers lottery ticket.
How is the slope measure and y-intercept of a line determined?
On a graph, the slope is the line in a plane completely specified by a point and a number. Mathematicians know that when an equation is written as y equals mx plus b, they can determine the slope measure and y-intercept, or slope-intercept, of the line. In this case, the m, or x coefficient, is called the slope measure and the y-intercept are the coordinates that solve the equation. For example, for y equals -2x plus 4, the slope measure is -2 and y-intercept is the coordinates, 0, 4. To test this result, replace the x with the first coordinate, 0. -2x 0 equals 0, therefore, 4 is left, resulting in y, or the y-intercept, being 4.
What is fluid mechanics?
Fluids are substances that flow, including gases and liquids. Fluid mechanics, or hydraulics, is the study of the physical behavior of these gases and liquids and their role in engineering systems. This includes the mathematics of the forces in and motion of substances, turbulence, wave propagation, and so on. Most fluid mechanics problems in engineering are mathematically modeled using differential equations. These models can also be applied to other engineering areas, such as electromagnetism and the mechanics of solids, because solids still move, albeit slowly. Other fluid mechanical studies include the compressibility of substances. In most cases, liquids are considered to be incompressible and gases are considered to be compressible. But there are exceptions in some everyday engineering applications, and they can easily be explored using mathematical modeling. Engineers also use special mathematical equations to determine certain characteristics of fluid flow, such as whether the flow is slow and smooth, laminar, or turbulent. For example, the ratio of inertia forces to viscous forces within a fluid can be expressed by what is called the Reynolds number. Laminar fluid flow can be described by the Navier-Stokes equations. For no viscosity, or an ideal flow called inviscid flow, the Bernoulli equation can be used. Finally, when the flow is zero, or static, the fluid is governed by the laws and equations of fluid statics.
How did Albert Einstein use mathematics?
German-born American theoretical physicist Albert Einstein. 1879 to 1955, is recognized as one of the greatest physicists of all time, but he was also a notable mathematician. In 1905 he developed the special theory of relativity, mathematically demonstrating that two observers moving at great speeds with respect to one another will experience different time intervals and measure lengths differently. That the speed of light is the speed limit for all objects having mass, and that mass and energy are equivalent. By around 1915, Einstein completed a mathematical formulation of a general theory of relativity, this time adding gravitational effects to determine curvature of a time-space continuum. He further tried to discover a unified field theory, which would combine gravity, electromagnetism, and subatomic phenomena under one set of rules, but he, and no one since, has ever found such a theory. For more about Albert Einstein, see History of Math.
What is a limit in calculus?
A limit is a fundamental concept in calculus. Unlike a limit mentioned above, as in a series or sequence, a limit of a function in calculus takes on a somewhat different meaning. In particular, a limit of a function can be described as the following: if f, x, is a function defined around a point C, but may not be at C itself, the formal limit equation becomes lim f, x, equals L. Thus, the number L is called the limit of f, x, when x goes to C.
What is a Vedic square?
Historically, in order for Islamic artisans to create a variety of geometric patterns, a Vedic square was often used. The Vedic is an ancient religion associated with India. For more information, see below. These squares generate patterns by the selection of number sequences and angles. Each square is made by taking a multiplication table and reducing all the numbers to single digits. For example, if a number in the table was 81, it would be reduced by adding 8 plus 1, or 9. Then, to get a design, for example, a certain line of numbers would be chosen, such as connecting all the number 5s. And by using a fixed angle of rotation with the lines, various designs were drawn. These number patterns are distinctively Islamic and help create many of the famous traditional Islamic geometric designs seen today.
How did the Hindu Arabic numbers evolve?
The evolution of the Hindu Arabic numbers was not a straight line from India to Arabia and on to Europe. In between, the Arabic cultures had more than one number sys tem to contend with. including at least 3 different types of arithmetic: finger reckoning arithmetic, counting on fingers. A sexagesimal system with numbers written in letters of the Arabic alphabet, and Indian numeral arithmetic. The evolution of the Hindu-Arabic numbers continued throughout time, and includes some good reasons for why our numbers look as they do today. For example, historians believe that between 970 and 1082, the numbers 2 and 3 changed significantly, rotating 90 degrees from their original written position. This is thought to be due to how scribes worked, sitting cross-legged. They wrote on a scroll they wound from right to left across their body. This caused them to write from top to bottom, not our usual left to right. The script was then rotated when the scroll was read.
What was the gambler's ruin?
In the problem, if a player begins with $10 and intends to play the game repeatedly until he either goes broke or increases his holdings to $20. The question asked is, what is his probability of going broke? The answer involves quite a bit of probability computation. For more information about the gambler's ruin, see recreational math.
What is a quadratic equation?
A quadratic equation is a second-degree, order, polynomial equation. Thus it is guaranteed to have 2 solutions, both of which may be real or complex. This is seen in the standard form x2 plus bx plus c equals 0.
How did some ancient cultures refine their calendars?
There were many different ways that various ancient cultures refined their calendars, and all of them entailed some type of mathematical calculation. One way to measure the length of a year was by using a gnomon, or a structure that casts a shadow. For more about gnomons and sundials, see p. 57. This was based on the apparent motion of the sun across the sky, with the shadow not only used to tell daily time but also to determine the summer solstice, when the shadow created by the gnomon would be at its shortest at noon. By measuring 2 successive summer solstices and counting the days in between. Various ancient cultures such as the Egyptians developed a more detailed calendar and, as a bonus, determined the exact times of the solstice. Around 135 BCE, Greek astronomer and mathematician Hipparchus of Rhodes, c. 170–c. 125 BCE, decided to compare his estimate of the vernal spring in the northern hemisphere, occurring in March, equinox with that made by another astronomer about 150 years earlier. By averaging the number of days, he estimated that a year was equal to 365.24667 days. A number only off by about 6 minutes and 16 seconds.
What are permutations, combinations, and repeatables?
In order to perform certain probability problems, specific counting techniques need to be used, including determining the number of permutations, combinations, or repeatables. The following explains each term. The examples are based on a set of 5 cats on a shelf A, B, C, D, and E, for convenience. Note, the cats can be arranged in 120 ways, expressed as 5x4 x3 x2 x1 equals 5. 5 factorial equals 120.
Who began the mathematical study of probability?
French scientist and religious philosopher Blaise Pascal. 1623 to 1662, is known not only for the study of probability but for many other mathematically oriented advances, such as a calculation machine, invented at age 19 to help his father with tax calculations. But it performed only additions, hydrostatics, and conic sections. He is also credited, along with Fermat, as the founder of modern theory of probability. For more information about probability, see Applied Mathematics.
Is math ever used to solve crimes?
Yes, certain types of mathematics are often used to solve crimes. For example, police officers and crime scene experts use geometry to determine the conditions behind the crime. Angles come in handy to determine from what direction a drop of blood originated. Determine where a car was coming from when it struck another car, or to otherwise reconstruct a crime scene. Length measurements can be used to determine the stride and shoe size of a robber from the person's footprints. Some higher math comes in handy to see how fast a car was traveling as it slammed on its brakes, a task solved by measuring skid marks. At murder scenes, forensic personnel can measure the splatter pattern of bloodstains on a wall to determine where the murdered person was standing, or even measure the size and angle of a bullet wound to determine the distance from, and position of, the murdered person to the murderer. Probably the biggest connection between mathematics and solving crimes is how mathematics teaches people to improve their thinking habits. Math is a good way to develop problem-solving skills. And in everyday police work there is always another problem to solve.
What is the set theory approach to arithmetic?
The set theory approach to arithmetic is defined in terms of the non-negative whole numbers 0, 1, 2, 3. These numbers are identified with specific sets based on the placement and number of brackets. For example, mathematicians identify 0 with the empty set, 1 is identified with. 2 is identified with, 3 is identified with. And so on. Each bracket is an interpretation of the empty set and 1, or.
What are the base SI units?
There are several base units at the heart of the International System, SI. The following lists the 7 base units: meter, distance, kilogram, mass, related to weight, second, time. Ampere, electric current, Kelvin, temperature, mole, amount of substance, candela, intensity of light. Still other SI units called SI-derived units are defined algebraically in terms of the above fundamental units. All the base units are consistent with the metric system called the MKS or MKS system, which stands for meter, kilogram, and second. Another metric system is the CGS, or CGS, system, which stands for centimeter, gram, and second.
What is a mathematical model?
Mathematical models are a way of analyzing systems by using equations, mathematical language, to determine how the system changes from one state to the next, usually using differential equations. And or how one variable depends on the value or state of other variables. Simply put, although working through the equations is not always simple, the process of mathematical modeling includes the input of data and information, a way of processing the information, and an output of results. A mathematical model can describe the behavior of many systems, including systems in the fields of biology, economics, social science, electrical and mechanical engineering, and thermodynamics. For example, modeling is usually used in the sciences to better understand physical phenomena. Each phenomenon is translated into a set of equations that describe it. But don't think that all the results of models are indicative of the real world, because it is virtually impossible to describe a phenomenon totally. Models are considered to be merely a human construct to help us better understand our surrounding real-world systems.
What is projective geometry?
Projective geometry is a branch of geometry that deals with the properties of geometric objects under projection. It was formerly called higher or descriptive geometry. Projection includes the transformation of points and lines in one plane onto another plane. This is done by connecting the corresponding points on the planes using parallel lines similar to shining a light on a person's profile and producing a silhouette on a nearby wall. Each point on the wall is a projection of the person's head.
What are quantitative and qualitative variables as used in statistics?
Variables are values used to come to conclusions in a statistical study. There are two main categories, quantitative and qualitative variables. Quantitative variables can be divided into three types. Ordinal variables are measured with an ordinal scale, in which higher numbers represent higher values. Even though the intervals between numbers are not necessarily equal. For example, on a 5-point rating scale measuring attitudes toward cutting back on air pollution. The difference between a rating of 2 and may not be the same as the difference between a rating of 4 and 5. Interval variables are measured with an interval scale, in which one unit on the scale represents the same magnitude of the characteristic being measured across the whole range of the scale. For example, the Fahrenheit scale for temperature is an interval scale, in which equal differences on this scale represent equal differences in temperature. But a temperature of 30 degrees is not twice as warm as one of 15 degrees. The third type is the ratio scale variable. This is a scale similar to the interval scale, but with true 0 points. For example, the Kelvin temperature scale is a ratio scale because it has an absolute 0. Thus, a temperature of 300 Kelvin is twice as high as a temperature of 150 Kelvin. Qualitative variables are measured on a nominal scale, or a measurement that has assigned items to groups or categories. With these variables, there is no quantitative information and no ordering of the items is conveyed. It is qualitative rather than quantitative. Religious preference, race, and gender are all examples of nominal scales.
How has math been used historically in architecture?
Historically, there has been a great connection between architecture and mathematics. Ancient mathematicians were architects and vice versa, using their skills to build pyramids, temples, aqueducts, cathedrals, and a range of other architectural structures we find beautiful and awesome today. For example, in ancient Greece and Rome, architects were required to also be mathematicians. During medieval times, most buildings and structures carried some symbolic reference to the church. The mathematical end of architecture was almost forgotten during this time. By the European Renaissance around 1400, a new kind of architecture developed that emphasized mass and interior space to produce aesthetically pleasing pictures similar to those found in paintings and sculptures. This led to an entirely new way of looking at architecture and altered its connection to mathematics.
What is plane geometry?
Plane geometry is simply the study of two-dimensional figures in a plane. Most mathematicians further define the plane as Euclidean. For more information about Euclidean geometry, see above. It examines such objects as circles, lines, and polygons.
How does a person calculate sales tax on purchases?
Most states and cities charge sales tax on retail purchases made by customers, from clothes to certain foods. This sales tax is based on a percent of the purchase price, with the percentage of tax called the tax rate. In turn, each state's tax rates vary greatly, often with the counties charging additional taxes. For example, in Vermont, the state and local sales tax rate stands at 5%. Florida has a state sales tax rate of 6%. And in various counties of New York, the sales tax rates start as low as 7.25% to as high as 8.75%.
How can I prove that 1 equals 0?
There is a way to show that 1 equals 0. And it includes an interesting proof. Consider two non-zero numbers x and y such that x equals y. If that is so, then x2 equals xy. Subtracting y2 from both sides gives x2 y2 equals xy y2. Then dividing by xy gives x plus y equals y, and since x equals y, then 2y equals y. Thus 2 equals 1, the proof started with y as a non-zero, so subtracting 1 from both sides gives 1 equals 0.
Who was Adam Ries?
Adam Ries, 1492 to 1559, was the first person to write several books teaching the arithmetic method by the Old Abacus and New Indian methods. His books also presented the basics of addition, subtraction, multiplication, and division. Unlike most books of his time that were written in Latin and only understood by mathematicians, scientists, and engineers, Ries's works were written in his native German and were therefore understood by the general public. The books were also printed, making them more readily available to a wider audience.
What are dice?
Dice are small cubes usually used in games of chance. Each dice is the plural, has 6 sides numbered with dots from 1 to 6. The dots are placed on the cube so that the sum of dots on opposite sides equals 7. The total number of dots on each die equals 21. They are mostly associated with certain types of games, with the simplest involving a player, or many players, who throw, or toss or roll, the dice for the highest sum. Dice have been around for more than 3,000 years, with evidence found in ancient Egyptian tombs, Chinese burial chambers, and the ruins of Babylon. The Greeks and Romans were avid users of dice and associated games, and they have been popular from the Middle Ages on. Dice have been made from many materials, including ivory, bone, wood, metal. and eventually plastic. Not all dice are square. The cube, or hexahedron, belongs to the group of 5 Platonic solids, or solids formed by regular polygons. Thus, other Platonic solids have also been made into dice, including shapes, polyhedra, such as tetrahedrons, octahedrons, and dodecahedrons, which are used for certain types of games. For more information about Platonic solids and polyhedra, see geometry and trigonometry.
What is a store discount?
Many stores, from apparel shops to bookstores, offer a discount on the retail price or, less often, on the sale price. For example, say a sweater that originally costs $50 is discounted by 25% during a sale at a department store. The customer will actually pay 75%, or 75/100 or 0.75, of $50, to determine the sale price. Multiply $50 by 25%, 50x 0.25 equals 12.50. Then subtract the discount from the original price to find the sale price, or $50. $12.50 equals $37.50.
What is linear algebra?
Linear algebra is the study of linear sets of equations. It encompasses their transformation properties and includes the analysis of rotations in space, least squares fitting, and numerous other problems in mathematics, physics, and engineering.
What are polar coordinates?
Polar coordinates are actually an alternative system to the Cartesian coordinates. In 2 dimensions, they mark a point on a plane by its radial distance, r, from an origin and a polar angle, 8. This method also uses trigonometric functions such as sin and cos, sine and cosine. For more about such functions, see trigonometry in this chapter. Polar coordinates in 3-dimensional space, also called spherical coordinates, use r and 2 polar angles, 8, to give the direction from the origin to the point. To compare, a 3-dimensional polar coordinate system overlaps the Cartesian system in several ways. For example, 8 is the angle between the line to the origin and the z-axis of the Cartesian, x, y, z, system. Is the angle, counterclockwise when viewed from positive z, between the projection of that line onto the x, y, plane and the x-axis.
What are triangles and how are they classified?
Triangles, or 3 angles, are polygons with 3 sides. A triangle's three line segments, or sides, are joined together at three vertices, endpoints. For all triangles, the sum of a triangle's three interior angles is equal to a straight angle, or 180 degrees. Triangles are classified by either the lengths of their sides, or, more commonly, the measurement of their angles. All triangles have at least two acute angles, but the third angle, which can be used to classify the triangle, can be acute, right, or obtuse. For more about these angles, see above. The types of triangles based on angles are: right triangle, there is one angle of 90 degrees. Acute triangle, all three angles are less than 90 degrees, or the triangle has three acute angles. Obtuse triangle, there is one angle greater than 90 degrees, or the triangle has one obtuse angle. Equiangular triangle, an acute triangle in which all angles are congruent, or when all three angles are equal. Triangles can be further classified by their sides, as in the following. Scalene triangle, there are no sides and therefore no angles that are equal, in other words, no sides are congruent. Isosceles triangle, two of the sides are equal, congruent, and thus the base angles are equal. Equilateral triangle, when all three sides are equal, congruent.
What is number guessing?
Number guessing is a game, some say trick. Some people can do number guessing in their heads, as long as the numbers are kept small. Have a person think of any positive integer n, not 0 or any negative numbers, and apply the following steps. For example, a person chooses the number 25 and keeps that number to humor herself. Ask the person to compute 3xn, 3x25 equals 75, ask if the number is odd or even. Odd, if the number is even, tell him or her to divide the number by 2, if the number is odd. Tell him or her to add 1 to the number, then divide that number by 2. 75 plus 1 equals 76 halves equals 38, tell him or her to take that number and multiply by 3, then divide by 9. 38x3 equals 114/9 equals 12.666. Take that number and multiply by 2, 12.666, x2 equals approximately 25. The answer should be the original number or close to it.
What is the geologic time scale?
The geologic time scale is a way of managing large amounts of time in a convenient chart. The scale is actually a measurement encompassing the entire history of the Earth from its beginnings some 4.55 billion years ago to the present day. The largest divisions include eons, eras, and periods. The smaller time divisions include epochs, ages, and subages.
What are some areas that numerical analysis addresses?
Areas addressed by numerical analysis include computing the values of functions, solving equations, optimizing functions, evaluating integrals, and solving for differential equations. For more about these areas, see mathematical analysis.
What are quartic equations?
Quartic equations are polynomial equations whose highest power of the unknown variable is 4. Put another way, quartic equations are algebraic equations whose highest exponent, or degree or order, is 4. For more about the history of solving quartic and cubic equations, see History of Mathematics. But take note, quartic equations are not the same as quadratic equations or second-degree equations in one variable, so don't mix them up.
What is multiplication?
The word multiply comes from the Latin roots multi, many, and pli, folds.
What are algebraic equations?
An algebraic equation, as with the equations defined above, is a statement in which two numbers, letters, or expressions are equal. But algebraic equations take this idea even further, most of the time. The objective is to try to simplify the numbers and the one, or more, variables in the equation. These can further be defined as any combination of variables or constants linked together by any operation addition, subtraction, multiplication, division, except division by zero. This type of algebraic equation is often referred to as a polynomial. See elsewhere in this chapter for more about polynomials.
What are the basic set operations?
There are several basic set operations, the most common being the intersection of sets, union of sets, and the complement of sets. The following lists these operations. Note, the first two operations obey the associative and commutative laws, and together they obey the distributive law. Intersection: the intersection of two sets is the set of elements common to the two sets. For example, the intersection of sets A and B is the set of elements common to both A and B. This is usually written as A and B. Thus, if A equals 1, 2, 3, 4, and B equals 3, 4, 5, then the intersection of A and B would be 3, 4. Union: the union of sets is the combining of members of the sets. For example, the union of two sets A and B is the set obtained by combining members of sets A and B. This is usually written as AUB. Thus, if A equals 1, 2, 3, 4, and B equals 3, 4, 5, then the union of A and B would be 1, 2, 3, 4, 5. Complement or complementation when the set of all elements under consideration must be specified. It is called the universal set. And if the universal set is U equals 1, 2, 3, 4, 5, and A equals 1, 2, 3, then the complement of A, or A, is the set of all elements in the universal set that are not A, or 4, 5. The intersection between a set and its complement is the empty or null set. 0. The union of a set and its complement is the universal set.
How did symbols for unknowns and knowns in algebraic equations develop?
In 1591, François Vide was the first to write and solve general algebraic equations by introducing the systematic use of letters as algebraic symbols. He used vowels, A, E, I, O, U, for the unknowns and consonants. The rest of the alphabet, for the coefficients, or knowns. But it was René Descartes who introduced a new way of using letters in the alphabet in his work La Géométrie. He used the letters at the end of the alphabet, X, Y, for unknowns and the beginning of the alphabet, A, B, for knowns. In many instances, these letters are italicized. This standard is still used in algebra today.
How did Gottfried Wilhelm von Leibniz advance calculating devices?
German mathematician and philosopher Gottfried Wilhelm von Leibniz, 1646-1716. Not only described the binary number system, a central concept of all modern computers, but also co-invented differential calculus and designed a machine that would perform the 4 basic arithmetic functions. By 1674 he had completed his design and commissioned the building of the Leibniz step drum, or the step reckoner, as he called his machine. The device used a special type of gear named the Leibniz wheel, or step drum. A cylinder with 9 bar-shaped teeth along a length parallel to the cylinder's axis. As the cylinder was rotated with a crank, a 10-toothed wheel would rotate from 0 to 9 positions, depending on its position from the drum. The movements of the various mechanisms would be translated into multiplication or division, depending on what direction the step drum was rotated. Although there were apparently only 2 prototypes of the device, both still exist. Leibniz's design along with Pascal's were the basis for most mechanical calculators in the 18th century. As with most such machines that could not be mass-produced, much less understood by the masses, they were more curiosities for display than machines put to actual use.
What other way did Archimedes use to find the area of a circle?
The Greek mathematician Archimedes, c. 287 to 212 BCE, Hellenic, also found a way to determine the area of a circle similar to the Chinese comb. A method he first recorded in his work, Measurement of a Circle, c. 225 BCE. He also used a sequence of wedges to determine the area of a circle, as the number of wedges or triangles inside the circle increased toward infinity, they became infinitely thin. By giving each small triangle a base, b, a line connecting the points where the wedges touched the circle's circumference, he determined that the area was 1/2 times the radius r times the base, summed over all the infinitesimal triangles, or sum, 1/2, rb. Because they all had the same height, that was factored out. Thus, the area became 1/2 r sum b equals 1/2 rc, with c being the circumference, or the sum of the bases b of all the triangles, since the bases make up what is perceived as the circle's circumference.
Why did the Egyptians need to develop mathematics?
Probably the most pressing reason for the development of Egyptian mathematics came from a periodic occurrence in nature, the flooding of the Nile River. With the advent of agriculture in the Nile River valleys, flooding was important. Not only to provide fertile soil and water for the irrigated fields, but also to know when the fields would become dry. In addition, along with the growth of the Egyptian society came a need for a more complex way of keeping track of taxes, dividing property, buying and selling goods, and even amassing an army. Thus, the need for counting and mathematics arose. Along with the development of a written system of numbers to complete and record the myriad of transactions.
What does continuous and discontinuous mean in calculus?
When talking about polynomial functions, we know that a polynomial function p, x, satisfies the limit function, lim p, x, equals p, a, in which a represents all real numbers. This is called continuity. But if f, x, is a function on an interval around a, then f, x, is continuous at a IFF, see above for the definition of IFF. Lim f, x, equals f, a, if it is not, then f, x, is called discontinuous at a.
What are some rules for combining exponents?
There are also rules for combining exponents, called the laws of indices. To multiply exponents with identical bases, add the exponents, such as 32x 33 equals 35, 3 is the base. To multiply like exponents, combine terms, such as 102x22 equals 10x2, 2 equals 400. To divide identical bases. Subtract the exponents, such as 103/10 equals 103 to 1 equals 102 equals 100, the denominator 10 has an assumed exponent of 1.
What do columns and rows mean when discussing vectors?
Vectors can be described by columns and rows. For example, two-dimensional and three-dimensional vectors are usually represented as a single vertical column of numeric values.
What is sabermetrics?
Sabermetrics is the study of baseball using objective evidence, such as baseball statistics. It uses scientifically based data and various interpretation methods to explain why teams win and lose. Sabermetrics was taken from the acronym SABR, or the Society for American Baseball Research, and was coined by baseball historian, statistician, and writer Bill James, 1949.
Upon what system were ancient measurements based?
Initially, people used different measurement systems and methods depending on where they lived. Most towns had their own measurement system, which was based on the materials the residents had at hand. This made it difficult to trade from region to region. Measurements eventually became based on familiar and common items. But that did not mean they were accurate. For example, length measurements were often based on parts of the human body, such as the length of a foot or width of the middle finger. Longer lengths would be determined by strides or distances between outstretched arms, because people were of different heights and body types. This meant the measurements changed depending on who did the measuring. Still, they were close enough for the needs at the time. Even longer lengths were based on familiar sites. For example, an acre was the amount of land that 2 oxen could plow in a day.
What is an abacus?
An abacus, the plural being either abacuses or abaci, is one of the earliest counting devices. The term comes from a Latin word with origins in the Greek words abax or abacon, meaning tablet or table. These words probably originated with the Semitic word abq, or sand. The device is originally made from wood but now usually including plastic perform arithmetic functions by manually sliding counters, usually beads or discs, on rods or wires. Contrary to popular belief, abaci were not truly calculators in the sense of the word today. They were used only as mechanical aids for counting. The calculations were done inside the user's head, with the abacus helping the person keep track of sums, subtractions, and carrying and borrowing numbers. For more about carrying and borrowing in arithmetic, see Math Basics.
Was mathematics always based on a logical foundation?
No, not all of mathematics was always based on a logical foundation. But some ancient cultures did develop certain aspects of logic in their thought. The Greeks were probably one of the first cultures to understand logic's role in mathematics and philosophy. And they studied the subject extensively. For example, geometry, as presented by Greek mathematician Euclid. c. 325–c. 270 BCE, had some foundations in logic. Greek scientist and philosopher Aristotle's, 384–322 BCE. Rules for syllogisms were also based on logic, and he wrote the first systematic treatise on logic. But his logic works were based on ordinary language making, them a matter of interpretation and subject to ambiguities. It was not until the development of calculus that most of mathematics was put on a logical foundation. By the 17th century, people such as German mathematician Gottfried Wilhelm Leibniz (1646–1716) began to demand a more regular and symbolic way to express logic. Logic truly became a part of mathematics around the mid-19th century. Especially with the 1847 publication of English mathematician George Boole's 1815–1864, the mathematical analysis of logic, and English mathematician Augustus de Morgan's 1806–1871, formal logic. Thus, mathematics began to encompass symbolic logic with precise rules to manipulate those symbols. See below for more about symbolic logic. Of course, nothing is perfect. Although mathematicians in the late 19th and early 20th centuries hoped it would be. They believed that all of mathematics could be described using symbolic logic and made purely formal. But in the 1930s, Austrian-American mathematician and logician Kurt Gödel, 1906–1978, put a damper on such an idea by showing that not all truths could be derived by a formal logic system.
What is the derivative of a function?
One of the most important, core concepts in modern mathematics and calculus is the derivative of a function or a function derived from another function. A derivative is also expressed as the limit of dy/dx. Also said as the derivative of y with respect to x. It is actually the rate of change, or slope on a graph, of the original function. The derivative represents an infinitesimal change in the function with respect to the parameters contained within the function. In particular, the process of finding the derivative of the function y equals f, x, is called differentiation. the derivative is most frequently written as dy/dx, it is also expressed in various other ways, including f, x, set as the derivative of a function f with respect to x, y, df, x, df, x, or dxy. It is important to note that the differentials, written as dy and dx, represent singular symbols and not the products of the two symbols. Not all derivatives exist for all values of a function, the sharp corner of a graph, in which there is no definite slope and thus no derivative, is an example.
What are the square and square roots?
When you multiply a real or complex number by itself, you are actually squaring that number. Mathematicians express the square of a number using the superscript 2, or. For example, 22. The square of a real number is always positive. Whether the number is 22, equals 4, or minus 22, equals 4, a negative times a negative equals a positive real number. A square root is a number that when multiplied by itself equals a specific product. For example, if t2 equals s, then t equals plus or minus vs, in which t is the square root and s is a positive number. For example, the two square roots of 16, v1-6, are 4 and minus 4, as 42 equals 16 and minus 42 equals 16.
How did certain ancient cultures count large numbers?
It is not surprising that one of the earliest ways to count was the most obvious, using the hands. And because these counting machines were based on 5 digits on each hand. Most cultures invented numbering systems using base 10. Today, we call these base numbers or base of a number system the numbers that determine place values. For more information on base numbers, see Math Basics. However, not every group chose 10. Some cultures chose the number 12, or base 12. The Mayans, Aztecs, Basques, and Celts chose base 20, adding the 10 digits of the feet. Still others, such as the Sumerians and Babylonians, used base 60 for reasons not yet well understood. The numbering systems based on 10, or 12, 20, or 60 started when people needed to represent large numbers using the smallest set of symbols. In order to do this, one particular set would be given a special role. A regular sequence of numbers would then be related to the chosen set. One can think of this as steps to various floors of a building in which the steps are the various numbers. The steps to the first floor are part of the first order units. The steps to the second floor are the second order units, and so on. In today's most common units, base 10. The first order units are the numbers 1 through 9, the second order units are 10 through 19, and so on.